2005 2 Design considerations of DG facilities. Customers' equipment shall be designed in accordance with but not limited to UL standards, Institute of Electrical and Electronics Engineers, IEEE, standards, the National Electrical Code, NEC, the National Electrical Safety Code, NESC, the Energy Reliability Council of Texas, ERCO, operating guides, CPS Energy Electric Service Standards, and any other applicable local, state, or federal codes or standards. Refer to figures 2001 through 2005. A. Protection and coordination. Customers' DG facilities shall be designed with listed equipment and protective hardware and software designed to prevent connection to de-energized CPS energy circuits. Customer shall also be responsible for protecting DG equipment in such a manner that CPS energy system outages, short circuits or other disturbances including zero-sequence currents and ferroresonant overvoltages do not damage the customer's DG equipment. Note: surge protection required as outlined in figures 2002 and 2004, b. Parallel operation. Customers' DG facilities shall be equipped with the necessary protective hardware and software designed to prevent connection or parallel operation of DG equipment with CPS Energy's distribution system unless the CPS energy voltage and frequency is of normal magnitude. C. Metering/measuring energy at DG facilities. DG facilities shall have provisions and necessary equipment to measure both the energy produced by the DG facility, PV meter, and any energy provided by CPS Energy for customers' use, PV billing meter, at DG sites. CPS Energy shall review all DG designs and make final determination on metering and communications equipment required including location. Note 1. The PV meter shall be located immediately adjacent to the billing meter unless otherwise approved by CPS Energy. Note 2. In no case will CPS Energy permit the PV meter to be located on floor S, other than the level that the revenue meter is located. A. Prevention of interference. Operating requirements for DG facilities are described in the DG manual. B. Wiring of self-contained PV system meter sockets. Customer shall furnish and terminate all conductors within self-contained meter sockets used for PV system installations. 1. Line and load conductors in the socket must have the same ampacity rating and not be smaller than number 8 AWG copper for 100 amp single-phase meter sockets, not smaller than number 6 AWG copper for 200 amp single-phase meter sockets, and not smaller than number 2 AWG for 200 amp three-phase meter sockets. 2. Line and load conductors must be identified at their terminations. Meter loops lacking properly identified conductors will not receive a CPS Energy meter. Customer assumes all responsibility for conductors that are improperly identified or terminated. 3. Meter sockets must have the line side, PV source, conductors connected to the line side, top, of the meter socket. Load side conductors must connect to load side, bottom, of the meter socket. Refer to figures 2002 and 2004. 4. Meter socket terminals are designed to accept either copper or aluminum conductors. 5. All wire ends must be wire brush cleaned. The wire brushed ends and terminals used with aluminum conductors shall have grit-fill joint compound applied to them before the terminal screws are torqued. 6. Customer must observe the terminal screw torque requirements. 7. Conductors formed within the socket's enclosure shall not rest on or press against other terminals. Note: in no case should customer connect PV system in parallel with CPS Energy source supply without first having a commissioning performed and written express consent of CPS Energy. F. PV AC meter disconnect. A disconnect furnished and installed by customer is required on the load side of inverters and before CPS Energy PV system metering equipment. The PV AC meter disconnect shall be located immediately adjacent to the PV system metering equipment and shall be readily accessible and capable of being locked in the open position. Refer to figure 2002 and 2004. Note: An additional disconnect to isolate the PV meter will be required where the interconnection is made at a location remote from where the PV meter is to be located. G. Labeling of equipment. Customer shall be responsible for all labeling of DG facilities equipment as outlined in Figure 2006. Such labeling shall be in place at time of commissioning. H. Interconnection of PV system. Interconnection of a PV system shall be in accordance with the NEC and other applicable codes and shall only be done on the load side of customer revenue metering equipment, refer to Figures 2002 through 2005. Raceways containing inverter output conductors shall be EMT for all above ground portions and shall not contain conduit bodies, LBs, or junction boxes unless specifically approved by CPS Energy's Electric Service and Metering Standards section. Exception. Conduit underground shall be permitted to be PVC type. The portion of conduit extending above ground shall be permitted to be Schedule 80 PVC provided it is supported securely and it does not extend more than 4 feet. 1. Load side interconnections shall be made on the load side of the customer's main service panel. A main breaker is required and shall be used in the bus ampere rating calculation to ensure the bus rating is not exceeded. Interconnections for residential installations shall be made at exterior panels. 2. Line-side interconnections shall be made in a junction box or auxiliary gutter ahead of the service disconnecting means. Junction box shall be suitable for the conditions, provided with locking provisions and be sized as per the NEC but not be less than 12 inches by 12 inches. Note 1. Conductors from junction box to PVAC disconnect shall be treated as service entrance conductors and shall be as short as possible, in no case shall the distance exceed 10 feet. I. Rapid shutdown of PV systems. Rapid shutdown shall be required in accordance with the NEC and shall be included in the design with proper labeling, refer to Figures 2002 through 2006. J. Grounding of PV systems. Grounding shall be as permitted by the NEC and in accordance with Figures 2002 and 2004. K. PV system conductors in attic spaces. Where PV system DC conductors are to be installed in attic spaces, conductors shall be installed in approved metal raceways/conduits in accordance with the NEC and other applicable codes. Where PV system AC conductors are to be installed in attic spaces, the conductors shall be installed in approved raceways/conduits with labels denoting PV AC conductors.